Hello, it's James from XRobots.co.uk. This is part 2 of version 3 of my BB-8 build. So I've already built 2 BB-8s and I've got version 2 here, so have a look back in that series to see this whole thing being built from the ground up. And now we're on to version 3, which I talked about last time, so check out part 1 of the version 3 series for a really long explanation of what makes this different and hopefully gives it all of the functionality that we see in the stage droid. So let's have a closer look at what I've got here. So what we've got, of course, is the main ball for BB-8, and this is very similar to the one I made for version 2. This one is quite a bit wider. The other one was 200mm, this is 300. And basically this is the channel that the main hubless wheel will drive in. This is 6mm thick, printed in solid ABS, and of course it has to be quite thin for the magnetic head coupling to work. The last one was the same thickness with 2mm skins on top of that, which is 8mm, and I felt that was pushing it enough, so I've done this one exactly the same thickness, even though it's wider. But of course these parts are printed on the bed this way up, so they're pretty strong. The grain cuts through this way, so looking at them this way, they're pretty tough. Each one of these took 4.5 hours to print, and I printed them on the Lulzbot TAS 5, so that's nearly 100 hours of printing. And I've got the rest just here, which I've been printing overnight and all sorts to get them done, so it's taken quite a while. These are all attached together with these rim parts, so we've got enough of these parts to go round the edge. You can see 2 on the inside there, and that's basically how it's fixed together. The rim is quite a lot thinner on this one. It was 20mm wider on version 2, but it's going to be okay. The aim of printing this in ABS is that we can solvent weld it all together with acetone and make it into one solid lump. So at the moment I've screwed it together, but all these screws will come out as they did with version 2. That will leave one big lump of ABS all solvent welded together, so it should make one big strong sort of barrel-like wheel to run in. And it needs to be pretty tough because of the ballast in the bottom that keeps it upright even with the head on top. Here's one of the ABS pieces, and they have to be ABS so I can solvent weld them, but one problem with ABS is it shrinks as it cools. So you can see, if we look over this contour, there's a slight dip here, and in fact that end dips upwards, and the other end dips down. There is a slight lip on that as well, so it's not quite an even curve. Obviously the ball's quite big, so it does average out as I put all these on, but there is an issue which needs more post-processing once this is together. Here's my ball all together. I've got all the pieces attached. You can see some of these edges don't line up as well as others. Some of them are a bit better. But anyway, what we need to do is solvent weld this all together. So I've got 2 pots containing acetone with a bit of ABS mixed in. One is slightly thicker than the other. And I'm basically going to go and seal up all these lines, solvent weld all these pieces to the rim here. And after that we're going to go and sand all these off, which I have a cunning plan for. For now we need to make this into one solid piece of plastic. So I'm just going to basically douse this whole thing in acetone and let capillary action draw it in between the pieces. We'll do it this way so I don't squash it. When this side's done we'll turn it over and do the other side, then I'll do all of these gaps, and then we can do some sanding. So I've just got quite a big brush. I'm literally just going to put acetone in all the gaps. We'll go around the inside of the rim once we've done the sides and tip that on one side as well so we can get it right in there. So this is the thin stuff that should run in there if we work it in. Slightly thicker stuff, it's a bit more of a paste but not quite. Just sort of work that into the gaps. So I've worked my way around the top edge and also the other edge, so this is now up the other way, and now I'm going to work my way around the inside here and make sure that acetone goes right down in that gap and get all of these rim parts put together on the 4 seam lines there. Chuck acetone in there. Working my way around a little bit as much as I can, filling up the cracks. So just working acetone on the inside here, Probably won't be able to go all the way up to the centre, so I'll need to work on that again with it on one side and on the outside to try and fill that. But I can fill up as much as I can, which at least makes a thin layer on the inside, so when I put some on from the outside it doesn't just run straight through the gap. So I'll just try and work that in as much as I can on each one. Done as much as I can on the outside, so there's mostly we're covered, so I'm just going around now on the inside. Now this is strong enough to put on its edge. Just working some more into the seams. Right, so all the parts are together. We've got something that's extremely substantial. I've sealed up the gaps as best I can in several layers, but it's incredibly tough now. I could take all these screws out and it'd still be just as strong. But yeah, looking pretty good. So the only thing I've got to do now is smooth it out a bit. So there's obviously quite a lot of ridges, which isn't particularly good for driving. And I'll also have to do the same on the inside, but only where the wheel runs. So that's going to be much easier just to get one smooth track. So basically I need to try and work out what to do about this. And there's quite a lot of plastic that's got to go. So it's going to be a fair effort with hand sanding. So I'm going to use an angle grinder with a sanding disc in it, which is one of these kind of, it's not quite a flapper disc, but it's got sanding things all the way around, and that should make quite short work of it. Right, so I've worked my way around. It's left quite rough edges, but I can take those off with a file and with hand sanding. It's melted the plastic quite a bit. It took a lot off in one go, so hopefully this is much smoother than it was. We can still see some ridges, but obviously that will get smoothed out once I stick the skins on, the same as the last one. Just going round finally with a bit more acetone and just filling up any holes that have emerged, which isn't too much, just some tiny cracks. Just really for strength more than anything else, because we're going to cover this eventually anyway, so we just need to make sure it's nice and strong so it doesn't fail in testing. Well, it's not totally perfect, but on average it's round, and it's a lot rounder than it was, which means it will run a lot more smoothly. I discussed this quite a bit in part 1 about how this is going to work, but very approximately what's going to happen is we're going to have another hubless wheel with a motor driving a wheel round the outside of this, which will drive it backwards and forwards, and then we're going to have another motor in some orientation or another which basically drives sideways, which brings all of the mass side to side, and the only thing left behind is this motor. The flywheel is going to be mounted on another axis which moves backwards and forwards, and that's pivoted along an axle which is carried by the first axis, i.e. this motor, sort of back to front, so that actually causes everything to swing side to side. So the first thing I've done is printed this collar for the motor, which is a bit of the mounting I used last time, and that means that I can sort of bolt this on, put a wheel on that's the right size, which is about 100mm, and I can work out exactly how to mount this wherever it goes, so I can work out the height this motor will be from the surface, so I can try and get this right, and I can try and mount this at the right height onto the internal chassis. Now last time I had a very similar thing to this, but because my ball was only 200mm wide, the distance of the internal hub that went round was also much narrower, and the motor was of course suspended on that internal hub. In fact, it was upright like this, and that meant that the motor was fairly well fixed to the internal hub. So now my ball is wider, of course that internal hub is going to have to be much wider, which means the motor is slung in there and the distance is much greater. So that's going to cause me some issues with that bending to actually hold this up, and of course it's got to be pretty much laid right down so it's out of the way of the other carriage moving sideways. So the basic approach I'm going to take to this is to build a much narrower carriage like I did in the last version, which fits in here with a gap each side, and then put wheels on the outside that run all the way around this rim to keep it in the middle. So it's kind of hard to explain by waving my hands, but let's have a look at some CAD. I've just started to flesh out the parts here, so I've drawn a few mechanical things here with blocks so I can work out the spacing and roughly how it's going to hang together. So the ball, of course, we've already drawn and we've already made, along with its red rims that hold all the segments together. So if we hide this, we can get a better view of inside. And what we can see is an internal hub, which is this green and yellow part. I'm calling the ball the cheese because it's a bit like a piece of cheese, and this is the banana. I've also got a part coming up called the trousers, but I haven't drawn that yet, so that's going to be for a future episode. So this internal hub called the banana has the main motor mounted on it there with its collar, which is similar to the one I just showed you, and that of course makes that whole thing go forwards and backwards inside the ball. Now the red part is the flywheel, which I've contoured to fit within the ball, and this time it's going to be filled with lead shot and glue so it doesn't rattle, but it's going to be much heavier than all those 2p pieces. So hopefully that's all the ballast I'll need. I've also contoured the inside so as it pivots side to side it doesn't hit the motor so easily. That thing, as you may have guessed, pivots around the silver axle that's held on the banana. So as I drive side to side, in fact what happens is the flywheel effectively stays upright and the rest of everything tilts. So the plan is to also mount the head control arm on the same axis that's pivoting as the flywheel and the motor that pushes it, so the head always stays on top and it's actually the ball that turns. That head control arm will also allow the head to move independently on top of that. So there's a few pieces missing, mainly the trousers, which is the axis that swings side to side on that axle, and it'll be driven side to side by a motor with a toothed gear running against this blue track. And that's really a placeholder. It will be a toothed track, like a curved rack, that will allow that motor to push the flywheel side to side, pivoting around the axle. But the first thing I need to do is try and work out how to get the motor mounted. So maybe I need to tilt the collar slightly, not in that axis, to kind of get the pitch correct there against the side of the ball. So what I really need to do is get the motor wheel on, get this collar printed and kind of measure it, then draw it in CAD so I can place it into the ball properly. And that means when it's attached to the banana and the wheels resting on the ball, then everything sits centrally, which is kind of crucial. I've printed this wheel, which is printed in solid ABS in the middle, and the tyre is printed in solid Ninja Flex using the Flexi extruder on the Lulzbot Mini. They're actually separate pieces which I can separate, but they are incredibly tight. And there's so much friction that I can't turn that tyre separately from the hub. Obviously being solid ABS, it's pretty solid. So this is what I did with version 2, and the wheel was actually thinner, so I've thickened this up a bit, but still left a recess there so I can get it onto the wiper motor. Now I'll put the bracket on, which is bolted through the existing holes that hold the motor together. And the plan was to put the wheel on and then align everything with the ground and kind of measure this bracket and work out where the mounting points are. Then that means I can draw a CAD version of this to put into the build so I can plan everything. The obvious issue that I've come across first off is that I can't actually put the wheel on because the bracket's in the way. So first of all I need to rethink the bracket, probably so this comes back a bit harder and then a piece sticks out. And that's one of the great things about trying things. I only printed this as a temporary solution in 10% infill just for sizing, and there we can see the first issue. So here's version 2, and I've left this cut out here so that the wheel can fit, so that'll fit on there. And obviously it fits in that slot. I've also done one with the slot on the other side in case I want to turn this whole motor up the other way and mount it. But I'm not sure if I do because the motor is higher than the wheel, so it won't actually run that way up, although it might be useful when I do the other motor for the side-to-side axis. And all I did in version 2 to attach this motor was basically screw it on. So what we've got is a sort of serrated bolt here with little serrations all the way around, and normally there's a metal wheel on that. So all I did was put a washer on and tightened up the plastic wheel against it so the washer gets sort of stuck on those teeth, and it pushes against the flat of the wheel to hold it, and then the rest is just held on with friction with another wheel and another nut on the other side, and that seems to have held up quite nicely in version 2, so I'm going to do the same thing again. Right, my wheel is fitted, so I forced a washer on there and tightened it up really tight against the serrations. It's actually, you can't quite see it, but it's gone a dome shape and got pushed into the plastic. And I've tightened up a nice new steel nut on there and actually used the proper socket set to tighten this up as much as I could. And what I've done is shorted out the motor so it doesn't run, so it's really hard to back drive. It's a worm gear anyway, but I can barely turn that with my hands. If I take the crock clips off and separate the wires out, it's still pretty hard to turn. But that wheel feels pretty secure on there. So even though it's really only a plastic wheel on a steel axle, it's pretty good, and as I say, that's how I attached version 2, which has held up all of that time. So now I've got this assembly with its test bracket. Essentially what I can do is, with various measuring tools, I can get this exactly square, and I can get a ruler and measure the height of the bracket. I can measure the height of that wheel, which obviously I know what it is from the ground because it's half the diameter of the wheel, but I can measure that from the bracket, and I can measure it sideways, and I can basically draw a CAD representation of this whole motor assembly to put in my main CAD and get the height exactly right. And here it is. So I've drawn the exact dimensions out for all of that in CAD. So I've got the right wheel placement, the right height of the bracket and everything. It's one solid lump, but I can use that to basically work out how this is going to be with the rest of the CAD. And here it is. So now I've placed that motor right in the bottom. If I just hide the ball again, and we can see I've placed that bracket in here. There's a couple of minor changes to give it more to grip on with, but that means that I can essentially align that and work out how everything fits together. So I've decided to lie it right down in the bottom there, and I'm a bit worried about the other motor clearance, but looking at it in real life, that's fine. So now I need to sort of sort out my banana thing, because there's lots of things that need to attach to that, like guide wheels, and I need to turn some of these crude blocks into real parts, and then we can get printing for that main part. So in real life, of course, that leaves the motor pretty much lying in the bottom of the ball like that, and then I can bring the other motor on that curved track backwards and forwards, and of course the flywheel goes around this motor and this moves with the flywheel. So there's no problem with sliding that backwards and forwards as long as the flywheel doesn't hit this motor or its mounting bracket. I think it should be pretty okay lying down there. I've split up and laid out my banana parts there, so I've split them up into lots of pieces so they can be printed on the print bed, and those parts overlap, so the parts nearest us are for one side and the other side is symmetrical. So obviously that blue part in the middle will overlap the two yellow parts. Now I've put lots of screw holes in there to screw it together. They'll also be solvent welded potentially, but I do need to get this to pieces at some point so I can service it and make sure I can get to that main motor and its wheel if anything bad happens. So we'll see whether a whole one of those can be inserted into the ball in one piece, or whether some of it needs to be bolted together so it can come apart. Here are all the parts for the banana, or at least part of it, so I've labelled them all with the colours in CAD as I printed them so I know how it goes together. That's the motor bracket as well, which I need to change over for the test one. So hopefully I can put all this together. I'm going to screw it together because I've got screw holes. Eventually it'll be solvent welded, but for now I'm just going to screw it, put it together, see how it fits in the ball. So I fitted that together. Of course this makes the internal hub that goes round inside. So this actually goes in and out in one piece, which is really useful because it means I can solvent weld this all together, can solvent weld the bracket on, and I know that I can still get it out in one piece once I've removed various other bits that will bolt on so that I can get to this wheel. In version 2 I can no longer get to the wheel because it's all solvent welded together and there's too much of it to reach inside, so if this nut were to come off or the plastic broke then I can't get to the wheel, so I need to be very careful that I can get to it in this version. So if you can imagine, we've got then the axle, if I can just get in there, which is suspended, and then the flywheel will tilt and swing on that, and it will be powered by a motor which also swings with the flywheel, and that gives me the side-to-side axis so that I can make this thing lean to steer and stabilise. So that's the basic plan. It's very tight, but I can get that in and out as well, which is good. The next thing for this is to make sure this sits in here properly. Obviously it's really wobbly and it scrapes on the plastic at the moment, so that's no good. And what I did last time was I had little wheels that faced outwards all the way round that held this centrally in the hubless wheel. It also needs some wheels to stop it doing this, so I need some that run outwards, pushing outwards. So basically in the last build I had one here, and I think I had 4 that were placed around inside pushing against this rim. So that's what's going to happen next time, to just get this thing running smoothly, and then we can talk about mounting the other axis. That's all for this episode, but don't forget to subscribe and check back for future episodes, and also check out 10 parts of building version 2 if you haven't seen it, including part 9, which is all about driving it in a big hall so you can see how it works. I've actually put the CAD up already on my GitHub page for this ball and this ball only, so if you want to use this for another project, you could turn it into an axle drive by putting sides on to suspend an axle going through that way, or you could use it as is for your own build. Then feel free to download it and print it. Obviously it is quite a big thing to print. It was about 100 hours and you need a printer big enough, and if you do it in ABS, don't forget you need an angle grinder. Alright, that's all for now.